Yes, dear participants, our next expert is Dr. Pradeep Dikshit, Associate Professor from IIT Bombay. Dr. Singh did his BTech from Madan Mohan Malviya University in 2001, MTech from IIT Bombay in 2003, and PhD from Nanyang Technology University, Singapore. His research interests are in MEMS, microfabrication, microsystem packing, 3D interconnections, non-conventional machines. He has experience of postdoctoral fellow at Georgia Tech University and senior researcher VIT Technical Research Center of Finland. He has many publications in international journals and conferences. Now, I would like to request Dr. Pradeep Dikshit to start his talk.
Certainly. Can you hear me?
Yes, sir, we can hear you, sir.
Okay. So if you allow me to share my screen.
Yes, sir, you can share, sir.
Yeah, just a minute. So let me. Okay. Are you able to see the screen?
Yes, sir, the screen is visible, sir.
Okay, great. Let me see the pointer option. Yeah. So a very good morning to all of you. I'd like to thank the organizer to invite me to share my thought process. Okay, and in this talk, I'm going to talk a very general presentation. Okay, that how do you approach it on a research problem during your PhD issue. Okay, so as the organizer mentioned, so currently I'm the associate professor in Department of Mechanical Engineering at IIT Bombay. And I'm also the associate editor of a Springer publication, which is known as a microsystem technology. So in this talk, I'm also going to talk about the perspective from a journal editor, that what exactly we look forward for when we receive some kind of a manuscript. Okay. So as let me just see. Okay. So as we mentioned. So let me just tell you my own personal journey. Okay, so I started my MTech degree here in IIT Bombay in 2001-2003 time frame, and then I went to NTU Singapore. Okay, where I did my PhD work. Okay, so after submitting my thesis in December 2007, I went to Georgia Tech. Okay, where I did my postdoctoral research. Okay, in the microsystem area, packaging area. And after spending 1 year in Georgia Tech, I went to Finland, okay, where I worked as a senior research scientist in an institute. Okay, so other two, NTU as well as Georgia Tech, they were universities. And after that, I spent some time on as a research scientist in a research institute. So this research institute is just like DRDO or ISRO institute within India. And after completing 6 years there, okay, I went back to my own alma mater, okay, which is IIT Bombay, and there I'm currently working on that. So if you look at my journey, okay, I experienced different research cultures. Okay, I experienced how this Asian culture work. Okay, how the US research culture is different from Asian culture, and after that I also experienced the European culture, which is quite open. Okay, so I like to also talk about the different cultures. Okay, and what kind of differences do you find them? Okay, so as far as my thing is concerned, let me see. Okay, usual problem. Let's see next. Yeah. So if I look at my research profile, so okay, I have 2 students who have graduated. Okay, another 4 are basically pursuing their PhD, and in total we have about 45 articles and a patent also. Okay, so let me first talk about this things. the organizer, can you just stop this thing, because whenever somebody is entering in the room, okay, there's a pop-up message which is coming at my screen. Is it possible to stop it?
Let me see it, sir.
Yeah, because I'm getting this pop-up message that somebody wants to join this thing. Okay. Right. So now if you look at this PhD study, right? Okay. So remember that although PhD study is mainly being carried out by a student, okay, it's not only a journey for him. Okay. Basically, the PhD journey is both for the supervisor and as for the student. Okay, both gain experience in that particular such area. Remember that your supervisor may be knowing about a particular problem, okay, or he may be aware of this kind of research domain, for example, manufacturing engineering, okay, but he may not be knowing much about in that particular problem where you are working on. Okay, so once a student completes its journey, okay, or completes PhD study, the ideal PhD is that PhD in which the student should know more than his or her supervisor. Okay, right? So PhD is just like kind of a kind of a marriage. So if you look at this comics, which is very popular among the PhD students, okay, so marriage is basically kept as a kind of similar to PhD, right? A typical marriage life in US lasts for 8 to 10 years, and PhD also goes in the same time frame. Okay, so it is important to make sure that you have a very good compatibility with your supervisor. Okay, that is one of the very key things. Okay, so what I have seen when I was a student here in IT Bombay, I was a bit kind of afraid of my supervisor. Okay, not because he was scary or something, but out of respect. Okay, I used to think that whatever my supervisor says, he's right. Sometimes I was a bit kind of disagreeing with him, but even though I used to follow his instructions. Okay, but later on when I experienced my PhD, okay, and also when I come back again as a professor here, what I realized that the student must not be afraid of asking questions and discuss the problems with the supervisor. Okay, that's a very, very key thing, because if the student is not really open with his supervisor, okay, then there will be kind of issues. Okay, at the same time, okay, supervisor also need to be very humble. Okay, and they should also be open for criticism. Okay, so it means that if you feel that as a supervisor, if I am absolutely right all the time, this is not going to be the case. Many times it happens that students suggest solution for a given problem, and many times it also that their solution approach is much more practical, much more efficient than the supervisor. Okay, so that is one of the key things. So now let me just talk about kind of a differences which I had experienced during my study. Okay, so if you look at the Asian culture, okay, so Asian universities, they have this kind of a hierarchical difference. It means that you have like PhD student, you have postdocs, and then you have the professors. Okay, and a common understanding is that supervisor is the boss. Okay, his or her opinion is always considered to be correct. Okay, but this is not the case if your supervisor is from different culture. So for example, in my particular case, okay, my supervisor was a Chinese guy, okay, and I was the only Indian students in his entire lab. Okay, many of my colleagues were Singaporean, Koreans, and Chinese. Okay, so what I experience here is that if you have a cross-culture supervisor, then this is going to be a kind of a benefit. Okay, so in Asian universities, mainly the projects are governed by the government money. As the previous speaker, Dr. Harpreet, has mentioned, that we don't see that much participation from the industry. Okay, but if you go to, let's say, European culture, okay, it's a very, very liberal. Okay, supervisor is just like your senior colleagues, because here he or she has spent more time on a research problem. Okay, he knows a little bit more experience. Okay, but he's not like a boss. Okay, so he's also trying to learn about that particular given problem, and they are very, very open to admit this fact that, okay, I do not know much about this problem. Okay, I will try to find out and I will get back to you, something like this. Okay, and as I said, that it is perfectly all right. Okay, to disagree with the supervisor, because if you are given a problem, okay, if you don't find it let's say appealing, okay, or if you don't agree with his or her solution approach, it is perfectly all right, okay, and so your supervisor will not really mind of that. Okay, now if you look at UK or France in for PhD problem, the PhD tenure, okay, the stipend period is typically about 3 years, 3.5 years only. Okay, it does not go beyond 5 or 6 or 7. Okay, so what does it mean? It automatically means that the research problems are well defined from the very beginning. Okay, whenever a student joins, okay, typically it happens that the supervisor has already got a funding project and his problem statements, okay, and objectives are crystal clear. Okay, they don't have to spend that much time on that. Okay, because of the limited funding period. Okay, now if you look at the US, okay, US is a kind of a balanced approach, okay, because you will find a lot of supervisors, students from Asia, okay, as you know that India and China and Korea and Taiwan, the 4 countries basically, they have the bulk of the international students here, okay. So US universities follows kind of a balanced approach, where the primary objective of the PI or principal investigator is to arrange the funding, research funding, and to initiate that everybody has this kind of a research facility to carry out the research work. Okay, and they have a kind of really a pyramidal kind of structure where you have a master students, you have a PhD students. PhD students typically report to a few postdocs, and these postdocs are going to report to PI. Okay, so that kind of a hierarchical structure which I have indicated in Asia is also predominantly found in US universities. Okay, and the research problems are mainly industry driven. Okay, so I am talking about from my personal experience, especially about the silicon based MEMS fabrication. Okay, so I had seen that most of the problems on which PhD students are working on, they are sponsored by companies like Intel, okay, or Apple or Samsung. Okay, so these are some of the companies which are sponsoring the projects at Georgia Tech, and those particular projects were basically divided into small parts, and each part was given to a PhD student to solve that particular problem. Okay, so they have a close interaction with the industry. Okay, because every PhD student need to spend about 3 to 4 months or even a semester to those companies to carry out their rigorous internship. Okay, so internship not only help them in understanding the real industrial environment, but it also help them later on to get employment in those companies. Okay, so that's extremely important. Now, if you look at the major steps, okay, what are the major steps during your PhD problem? So as you know, okay, the very first thing is that you are given a, let's say, research topic or research problem. Okay, now you need to make sure that you have the relative academic background to carry out your research work. Okay, so there could be specified courses, okay, which you need to carry out. Okay, so here I have highlighted some of the common courses, okay, which are known as a general courses, okay, which every PhD student should basically take in their PhD course. Okay, so for example, finite element analysis or computational fluid dynamics, these are the courses which is going to be taken if you want to carry out any kind of a numerical simulation work. Okay, design experiments, okay, DOE, where you will understand different kind of optimization method, DOE method, Taguchi method, and so on. Okay, plus numerical analysis, data analysis, measurement. So these are some of the courses which I would recommend that every PhD student should take depending upon what kind of choices they have. Okay, literature review, as we'll talk about a bit later. Okay, that the literature review is kind of a always ongoing process. Okay, literature review step does not stop. Okay, it is always going to be going on process. Okay, then the second step is going to be defining a research problem. Okay, then defining the research objectives, okay, which are basically a kind of small segments taken from the research problem itself. Okay, after that, depending upon your research problem, whether you have to carry out experiment or whether you have to mainly talk about the numerical or analytical parts, this you have to ensure it. Okay, now whether you pick up experimental study or numerical study, it all depends upon your personal interest. Okay, if you are good in, let's say, simulations, if you're good at the analytical thing, then you should choose a topic which is more on the mathematical analysis part. But if you like to do something like hands-on kind of work, then my recommendation is to pick up a experimental work. Now, whether you choose a experimental work or simulation work, it all depends upon the resources. What kind of resources do you have in your institute? Okay, because carrying out both experimental part is going to be time consuming and it's going to be expensive process. You need consumables, you need continuous working machines. Okay, similarly, if you look at the simulations, okay, depending upon what is the dimensional domain of the simulation, you need to have a sufficient computational power. Okay, so depending upon your uh, study, your experiment, your simulation, okay, you will get basically some kind of results. Okay, and these results you need to be present before your supervisor, either in a weekly format or monthly format, or depending upon what kind of agreement you have with your supervisors. Okay, then there comes a very important talk about the publications, right? So there are two approaches, okay, which I have seen in my academic career. Okay, few professors insist that I will publish a publication, okay, which will basically comprising of the entire work of PhD. Okay, it means that they target to have a publication, okay, at the near end of the PhD study. Okay, but the more popular approach which I have encountered during my own PhD is that if you try to publish, let's say, paper, let's say annually, for example, okay, that you have achieved a particular research objective, and if you have got some kind of a publication, some kind of results, okay, you try to formulate those results in form of a publication and submit that particular manuscript. Okay, now which approach is better? Again, both approaches are fine. Okay, but I would personally recommend the first approach. Okay, because if you have, let's say, a couple of publications, 2, 3, 4, 5, okay, and if you include that in during your PhD thesis writing, that the chapter 1, chapter 2, chapter 3, they are taken from the this and this publication, or chapter 4 has come from this particular publication, what will happen? It will have a very, very positive impact on your thesis reviewer. The person who is reviewing your thesis, he will know that this particular work has already been peer reviewed and accepted as a publication. Okay, so it is going to be having a very, very positive impact. Okay, and finally, based on your publication, you are going to summarize in form of a publication itself. Okay, so now let me just give me just 1 minute.
Sir, kindly unmute yourself.
Okay, sorry, can you hear me now?
Yes, sir. Yes, sir. It's fine now.
Okay, okay, by mistake probably. Okay, so let me just start it from this particular slide. Okay, so I thought that somebody might have not read it. So the literature review is basically the very first step in your PhD study, right? And as I mentioned to you that the basic objective of this literature review is just to know that what is going around your research topic. Okay, that what are the different groups which are working on that particular area, what they have already done. Okay, what are the loopholes in that particular area. For example, let me just give you example of my own PhD research work here, which is going on in IIT Bombay. Okay, so one of my student is currently working on a problem in which he has to fabricate a very deep holes. Okay, deep holes means that we are trying to create a 1 millimeter deep holes, okay, having a size of 100 micrometer. Okay, so 100 micrometer is a diameter, and the depth of those micro holes is going to be 1 millimeter. Okay, which is mean that aspect ratio is going to be 10. Now the material is the glass material. Okay, so glass, as you know, that is a borosilicate glass or quartz. They are all form of glass, and glass is a brittle material. Now the question here is that if you want to create such kind of micro holes, okay, what are the challenges? Okay, so if is it a traditional material, okay, soft material metal, then you can use drilling process, right? But in this case of brittle material, you cannot use drilling. Okay, now the question is what else you can use? Okay, so ultrasonic machining, abrasive jet machining, but they are not able to create such a kind of a deep holes. Okay, so this is a kind of a research problem. Now, so if I want to carry out this literature review, okay, what does it mean? I need to find out what are the research groups. Okay, so after reading papers, attending conference papers, okay, I know that within India we have a very active group in IIT Roorkee. We have a group in IIT Madras, Professor Samuel group. Okay, some of the work has been done in Vijay Bhattacharya group in Jadavpur University, right? So idea here is about this, the objective of the literature review is just to be aware of the current status of this technology, right? What has already been done, what are the loopholes, what has not been done in that area. Okay, while reading the papers, you will know the research groups, okay, and what are the active kind of things which is going on in that. At same time, remember that when you try to find out this information, okay, most likely most of us will go through Google, right? Either Google Scholar or Google or different kind of a thing, and we will keep our topic and we'll try to find out what kind of publication has been published in that particular area. Okay, so remember that right now there are so many journals which have come lately. Okay, and believe me that almost half of them are not good journal. Okay, so you have to be sure that you are reading a good quality, okay, and peer reviewed journal. Okay, so this is a very important, and I will talk about what do you mean by quality later on. Okay, but whatever articles which you are going to read, they have to be good reputable journals. Okay, what you can do is that suppose you are working on that part area, let's say that micro machining, okay, or let's say additive manufacturing. Okay, so Google Scholar basically allows you this kind of facility that you can link your email address, okay, and you can connect to those keywords. So for example, additive manufacturing, right? So whenever any new paper will come in that particular area, okay, you will get an automatic notification that so and so journal paper has been published, okay, so that you can keep a track on the upcoming journals. Okay, right? So in order to carry out any kind of a literature review, my recommendation is that first start with a good review paper. Okay, so good review paper is a kind of a paper in which a author has basically kind of accumulated all kind of prior publication in that particular domain. Okay, so try to start your literature review by reading a good paper which has going to have high citations. Okay, so do not go for very old review papers. Try to read a review paper which has been published in, let's say, last 3-4 years, so that you can keep yourself up to date about the technical development in that particular area. Right? Now, let me go to the next slide. Okay. So when you have found a review article or any technical article, okay, remember that you don't have to simply read it. Okay, you have to understand that particular journal paper. Okay, and you should also criticize. What do you mean criticize? So do not believe completely what the author has said in that particular review paper. Okay, you can think about, okay, whether, for example, let's say that somebody has indicated that they have created a micro hole in glass by using a standard drilling process, right? This is a statement somebody has mentioned. Then you need to understand whether it's possible. Okay, if it's possible, what is the aspect ratio? Can you create a very deep holes using the conventional drilling process in glass material? Okay, so probably not, right? So you need to understand the pro and cons of that particular technical statement which they have written in that particular paper. Okay, so this particular thing is time consuming process. Okay, you have to spend a lot of time on reading and understanding a particular paper. Okay, right? So try to understand, okay, the current status, try to find out the loopholes. That is very, very important. This is where you will basically get your problem statement, right? Try to find out what has been done, okay, what has not been done. Okay, if they have not done it, what was the technical challenge? Okay, whether the process was very expensive, or for example tool wear is problem. Okay, in case of conventional drilling, as an example which I'm giving right now, okay, whether if you use a mechanical drilling, whether the glass will break or not. Okay, so these are all kind of shortcomings which are basically you will be aware only after reading this kind of papers here. Okay, so remember, okay, that these shortcomings, okay, whatever problems, whatever loopholes you have found, okay, whether it can be solved or not. Okay, many times it happens that particular problem, let's say, has been not been solved. Okay, so you also need to understand what were the reasons why people have not attempted to solve that particular problem. Okay, is it a fundamentally problem, or the process is going to be too complicated? Okay, so all these things you will be only be aware after reading this kind of a paper. Okay, so my recommendation is that whenever you read couple of papers, okay, try to create a report. Okay, a short 1 or 2 pages report. Okay, in form of a PPT. Okay, because this is the report which you have to present to your colleagues or your supervisor. Okay, and supervisor typically they do not have that much time to go through a detailed report. They want to understand what is the problem in that particular paper. Okay, what has been done and what has not been done. Correct. So once you read a particular paper or conference paper, okay, or if you're listening to any video on YouTube on that particular technology, and after that you need to summarize it. Okay, so paper can be of 6 to 10 pages, but you need to formulate a 1-page summary of that particular article in form of a PPT. Okay, so literature review in short is a kind of a testing, okay, of your reading skills, listening skills, and writing as well as speaking skills, because you need to make a PPT, you have to make a detailed report, and after that you need to communicate that particular report to your professor. Okay, now one thing what I have seen lately, and also which is very useful, that many of the PhD student, once they have carried out a detailed this literature review. Okay, so suppose you have gone through 5, 10, 20 articles. Okay, you are in position to write a small review articles of your own. Okay, so for example, again coming back to the micro machining of glass material. Okay, so if you look at, if you have gone through different technical papers, okay, what you will have, you will know that what are the pros and cons of different technologies, right? Whether you can use ultrasonic machining or not, whether you can use a milling process or not, or whether you can use a laser process or not, for example. Okay, so once you have completed a detailed literature review, okay, you are in position to write down your own review articles of a specified theme. Okay, so this is what I have seen lately, that several research groups are coming out of this particular technology. Okay, that students carry out detailed literature review, and after that, based on their literature, they basically formulate a specific theme of that technology, and they write down their own literature review. Okay, which is a good thing, very, very good thing. Okay, so let me just tell you, okay, this is just again from the comic book. Okay, so as I said in the beginning, the literature review does not mean that you are going through the paper itself. Okay, you have to understand it also. Okay, you after reading that particular paper, you should be in position to criticize it. You should be able to distinguish what are the pros and cons of this paper, right? What is a special message of this paper? What is the overall summary of that particular thing? Okay, so very much very time it is possible that you are reading a paper. Okay, in that particular technical article, you encountered something which you could not understand. Okay, so in order to understand that particular thing, you need to refer another article. Okay, so that's why I said that literature review does not stop. Okay, it does not stop after your first year or second year. Okay, it's always ongoing process. Okay, so please start reading these technical papers. Okay, and taking basically care that you should know that what is going on around your particular topic. Okay. Now coming back to the defining the research problem. So many times it happens that you have joined a research group which is already a kind of well-established group, okay, in which somebody is already working on some kind of area, and on that particular area, okay, every PhD student, while they are finishing their PhD, they will tell you that what is the future scope. Okay, what are the remaining problem statement which he or she could not solve it because of the time limitation. Okay, so your supervisor may give you this kind of a ongoing problem, or the problem could be completely new. Okay, your research problem could be incremental. Okay, it means that you are going to solve kind of an incremental value, or it could be really kind of a path breaking problem. Okay, so I just now I was talking about this thing. Okay, so this particular problem is not really a path breaking. Okay, but it is going to be kind of an incremental value. So in my group, we are working on a process which is known as an electrochemical discharge machining process. Okay, so this particular process, this is not an industrial process yet. Okay, it is still on the research phase because people are trying to work on that. Okay, so if you look at the problem statement, we wanted to create from the high aspect ratio feature in a glass material. Okay, so you can do this kind of process by femtosecond laser. Okay, so femtosecond laser is already an industrial process, well-established process, but the process is very, very expensive. Okay, so if you look at this statement, okay, this statement is not going to be any kind of path breaking idea, because the problem can be solved by alternate way. But if you do it by let's say ECTM process, okay, it is going to be having a incremental contribution in the already known knowledge, right? Then the question is that how this problem, if you solve it, how it is going to be benefit to others, right? Is it going to be useful for industry? Okay, if not industry, then what is going to happen? Okay, so whether this is going to be fundamental research or is going to be really applied research. Okay, so if you have listened to the previous speaker, okay, Professor Harpreet, he has mentioned a very, very important point. Okay, right now our Indian government is asking us as an IIT that look, you have most of the old IITs, they are roughly about 50 years old, right? So we have been supporting you from last 50 years. Okay, now it's your time to stand up and try to help the small and medium scale industry within India. Okay, if you are not going to help the industrial problem, okay, there's no usage of the previous research. Okay, in the hidden terms, government is asking us to that we will only support you, okay, if you try to solve an industrial problem. Okay, so this is very, very important for every new PhD student as well as the faculty member to understand that try to focus on some of the problem which are going to be beneficial to industry. Okay, so this problem which I have mentioned here, how to create this high aspect ratio vias or holes in glass material, this is required in microfluidics, radio frequency MEMS application for various optical applications. Okay, so this problem has a direct industrial application. Okay, so present status, who are working, difficulties, challenges which you have already identified through your literature review. Okay, you know what are the technologies, what are the pro and cons, what has been done, what has been not been done. Okay, so try to find out the loopholes, the challenges, the problem which has not been solved, and pick up that particular unsolved problem through your detailed literature review. Okay, I think I have mentioned earlier that whether any problem, whether it's experimental or numerical, it totally depends upon what are the facilities which are available in the parent institution, or whether if you have any kind of collaboration, that whether those facilities are available within the collaborators or not. Okay, so depending upon, so you should also know, or you should be aware of the what kind of facilities are available. Okay, if you are proposing a research problem, okay, which cannot be solved using your own parent institutions or your collaborative institution, then you are going to be in big trouble. Okay, so try to find out and then pick up a problem on that particular area. Okay. Now remember, okay, that the world is so big. Okay, it is very much possible, very much likely, okay, that more than one research group is working on the same problem. Okay. So remember this cartoon which I have shown here, it is a true. I have personally seen, okay, that a PhD student was working on a problem and then he encountered a kind of research article which is similar to the problem he was trying to solve. And if it has been published, okay, then it is going to be a big issue, right? So there, for a given research problem, there could be multiple approaches. Okay, multiple research groups might be working on that particular problem. So this is where the continuous literature review is going to be helpful. Okay, so if you are continuously performing literature review or you are aware of that, then you will be knowing that which group is working on which process. Okay, so please ensure that you have some, let's say, novel thing or some different thing which you are trying to utilize it in solving the same research problem. Okay. Now, what will happen if you have a, let's say, multiple research group? It is very much possible. Like I said, within India, IIT research, Roorkee research group, IIT Bombay research group, Jadavpur University, Madras, IIT Madras, they're all working on this kind of similar problem. Okay, so each one we have some kind of a differences, some kind of novelty, and we are trying to basically utilize that novelty in our research work. Now, this is where this fast publication comes in picture. Okay, so if you wait for let's say a couple of years, okay, before you decide to publish your paper, okay, then it might very much possible that somebody else may come out with the kind of a publication, okay, in that. So from this point of view, a fast publication is going to be helpful because it will tell the others, okay, that a group in IIT Madras or IIT Bombay is working on this particular problem. Okay, so normally the credit will go to the first research group or first few research group who have shown the outside world that this is the problem and this is what our solution is. Okay, so this is where again the importance of publication will come in picture. Okay, now you have got a problem. Okay, you have identified that this is the kind of problem we are going to work on mainly. Okay, and so what you can do is that you can break that particular problem into smaller parts. Okay, so for example, this micro machining of high aspect ratio holes in a glass material, this was a problem statement. Okay, now how will you achieve it? Okay, so I can achieve this thing by I will break this problem into a few smaller parts. Okay, the first one is the numerical simulation. Okay, I will basically try to find out, okay, that what is going to be the basic physics behind the ECDM process, which I have decided to utilize it. Okay, what is going to be the numerical simulation? Can we theoretically predict what is going to be the material removal rate? Okay, so the first step would be numerical simulation. Second objective is going to be the experimental verification or process parameter optimization. Third one could be the other things, right? That you want to carry out the actual thing, whatever the challenges which will come, you are going to solve it. And finally, you have to show the application of that technology into some useful industrial product. Okay, that is very, very important one. Okay, so you break it down into smaller segments. Okay, each segment should be complete of its own. Okay, it should not, and they should be also be linked. So first you will do numerical simulation, then you will do experimental process parameter optimization, then you will do experiment, and you will check whether the numerical results and experimental results are they matching it or not. If they are not matching, you need to find out what is the root cause of that. Okay, depending upon the root cause, okay, you need to do some kind of changes in your numerical model, and then you need to repeat again. Okay, so in order to visualize these statements, their objectives, okay, and the timeline, a flow chart comes in very handy. Okay, so you should basically able to highlight that what kind of flow chart you can create, which will show all these research objectives and how to achieve them. and what is going to be the timeline. That is going to be critical part. Okay. Now, I have already mentioned to you about this particular point, whether you decide to go for experimental projects or numerical approach. Okay, it all depend upon the problems need, okay, available facilities and your own strength. Okay, that is very important. Okay, so as I said in the beginning, that you need to find out that what is your comfortable zone, right? Are you good in the hands-on experience, or you are good in simulation work? Okay, or you have not decided. Okay, so if you have not decided, of course, then PhD is going to be a good time where you can learn new skills and you can use it. Correct? So besides your own strength, you need to find out the easy accessibility of the equipment, software. Okay. Now, what I would say that right now this a combined approach, in which we carry out some of the experimental work, some of the simulation work. That approach is very recommended right now. Okay, so for example, you have seen that because of the COVID situation, okay, many of the institutions are closed. Okay, and because of that, if somebody has chosen, let's say, pure experimental research work, okay, then you can easily find out that that person might be in trouble, because that person is not able to access the equipments. Okay, but if you would have chosen a hybrid approach, okay, in which you are doing, let's say, 70% experimental work and 30% numerical work, then in this spare time, okay, you are still in position to carry out your numerical work. Okay, so my personal idea is or recommendation is always to go for a hybrid approach. Okay, so you should have some kind of a numerical approach, okay, numerical results which can be validated with experimental work. And at same time, pure experimental work is also not recommended, because carry out this kind of a detailed extensive experiments are going to be very expensive and time consuming. Okay, and in case let's say that you have a breakdown of machines, or due to some reason something is not available, okay, then you will be in kind of a trouble. Okay, so hybrid approach is always recommended, where you will have a little bit of numerical simulation, a little bit of experimental work. Now, depending upon your own strength, you can decide whether you want to go for 70% numerical work and 30% experimental. This is completely comfortable with you and your supervisor. Okay. Of course, I think dynamic experiment simulations. Okay, yesterday I think Professor Ravikant from IIT Ropar, he has explained in detail about the dynamic experiment DOE methods. Okay, so I'm not going to talk about these things in detail. Okay, but it is very important to have a very clear understanding about that what kind of experiments you are going to perform. Right? What are their objectives? Right? What is going to be the different kind of variables? Okay, so whether variables are independent variables or dependent variables, and what should be the outcome? Okay, you should be very kind of a clear cut about that particular part. Okay, right? So depending upon what kind of experiments you have decided, okay, you need to also carry out need to ensure that these experiments, okay, should not be carried out only at one time. Okay, all these experiments must be carried out multiple times, so that we can confidently tell that these experiments will give us some kind of a repeatable results. Okay, this is very, very important. Many times what I have seen during my interaction and during the thesis review of different colleges, PhDs, what I've seen that these guys, they have done experiment only at one time. Okay, they have not performed it multiple times, let's say 3-4 times, and there's always some kind of a doubt which will create. Okay, it means that all these experiment must be give us some kind of repeatable results. Okay, and in the repeatable, when you carry out some kind of a repeatable results, you will check, you will see that the outcome, the output data is not always the exactly same. Okay, there's always going to have some kind of a variation. Okay, so whatever error bars which you are going through, okay, which you are getting it, you need to plot those error bars while explaining your results. Okay, this is extremely important. Okay, as an editor, when I'm getting this manuscript, okay, if a manuscript does not show multiple results or repeatable results, that manuscript is going to be rejected. Okay, or if not rejected, then there's going to be a critical remark during the review process that how many times you have carried out the experiment, please indicate. Okay, so this is extremely important here to understand. Now, how you carry out your experiments? Okay, as you know that you can vary one parameter at a time, or you can do full factorial or fractional factorial experiments. Okay, so we have different kind of schemes. Okay, Taguchi method is basically there. Okay, which will help you in choosing those variables and to minimize the number of experiments which you have to carry out. Okay. Now, all those audience, if you have any questions, you can please write down those questions in the chat box. Okay, and I will take all the question at the end of my presentation. Okay, what is a good experiment? Okay, as I said already, that good experiment must be repeated, okay, multiple times so that we can show the variations. Okay, it should have, ideally, it should have the minimal variation in the output results. If we are keeping all the input parameters same, and if we are repeating experiment 2, 3, 4 times, the output value should not change much. Okay, so now if you have carried out this experiment in the lab condition, okay, ideally the goal is here is that you, for example, right now the demand is that whatever research project which is being carried out in an academic environment, it should help industry. Okay, so let's say that based on my results, if some industry wants to replicate those results, okay, the results should be basically give the similar kind of a result. Okay, so whether the experiment is performed in a lab condition or in an industrial environment, there should not be much variation in the results. If there is a variation, then we should have some kind of proper reasoning that what is the reason behind that, why the output data is going to be changed if the same process, same experiment is performed in lab condition or in the industrial conditions. Okay, now, so now you have carried out your literature review, you have done some experiments, simulation work, and you have got some kind of results. Okay, now the important part which is basically needed is the publication. Okay, so if you feel that there is some kind of novelty in your approach, okay, you have got some very interesting results which has not been reported earlier. Okay, if you feel that your process, your experiment has some real new things, then I would recommend you to go for this kind of IP disclosure, invention disclosure. Okay, where you can basically protect your idea. Okay, you go for a patent. Okay, but writing a patents, okay, is not an easy task. Okay, both in terms of timeline and also in terms of money required, right? So if, okay, so a typical US patent, okay, takes about 5 years. Okay, so for example, the research work which I have carried out in my PhD work, okay, based on my PhD work, I filed a patent, okay, and it took me almost 5 years. I had already graduated, and that time it was granted. Okay, so it is going to be kind of a long process. So what we normally people do, okay, they file this kind of IP disclosures, okay, proprietary filing, and after that they go for this kind of publication. Okay, now after carrying out this detailed literature review, okay, you should be in position to find out whether a particular journal is good or not, right? So there are very reputable journals. Okay, so for example, I am from this mechanical engineering manufacturing field. Okay, so for in our field, as some of you might be knowing, Journal of Material Processing Technology is very good. Journal of Manufacturing Process is very good. Okay, ASME journal is very good. International Journal of Machine Tool and Manufacturing. Okay, so these are some of the journals which are going to having a very high impact factor. Okay, and they are being published from a long time. Okay, but at the same time, I have seen that many institutions, okay, even NITs, they are not really careful. Okay, I have seen that a typical PhD student in NIT is having 10 to 12 publications. Okay, now let me tell you that at present I am the coordinator of the Institute Postdoc Committee in Mechanical Engineering. Okay, so we have a committee which decide that which postdoc application after PhD will go through or not. Okay, and as this role, I'm getting a lot of applications from NITs, okay, and also from some private institutions and also from IITs. Okay, so I'm seeing a lot of this kind that many of the publications, even from NITs, they are not really good. Okay, they have chosen a journal which does not have a very good reputation. Okay? And because of that, okay, their postdoc applications do not go through. Okay, so remember that this NIT, which the criteria they are following, that SCI and Scopus indexing alone is not, should not be the criteria. Okay, so once you carry out your work and if you feel that you have a good results, try to publish in a good reputable journals. Okay, and this is where you should know that as a PhD student, you should know that what is the really the true quality of your work. Okay, is it really some kind of novelty? Does your work really add to some kind of contribution to already known knowledge? Okay, whether if the process has already been demonstrated by some others, whether in your process can you lower down the cost? Okay, so any kind of a new things should be there. Okay, and based on that particular thing, you should basically write down a manuscript and submit it in good reputable journals. Okay, so that's some of the key things which I want to highlight here, that SCI Scopus indexing alone is not a criteria. Believe me, we are rejecting a lot of applications from NITs from this point of view. Okay, now once you give me 1 minute. So once you try to start writing a manuscript, okay, you have to make sure that your manuscript is free from any kind of plagiarism. Okay, so this is very, very important again. Okay, now once you submit a manuscript to any journal, okay, most of the journals, most of the reputable journals now, they have their own plagiarism check software. Okay, so we have something called Turnitin or Urkundu. Okay, these kind of softwares, they are basically used by most of the reputable journals. Okay, so as soon as the manuscript is submitted, okay, that particular software prepares a report. It tells you that we have got, let's say, 10% similarity to this work or 12% similarity to that particular work and so on. Okay, and this report is submitted to an editor. Okay, so as an associate editor of microsystem technology, whatever manuscript comes to me, okay, along with that, I also get this kind of a similarity report. Okay, and once a similarity report goes beyond a critical value, okay, the manuscript is automatically rejected. Okay, it says that you have so much similarity, so on. Okay, so my recommendation is that try to check this similarity by yourself. Okay, now what could be the problems I'm going to talk about a little bit later. I think it's going to be okay. So this is going to be thing. Okay, so now once you start writing a manuscript, draft manuscript, okay, so writing manuscript is what I tell to my own students is just like a telling a story. Okay, but of course story should be based on the facts, based on your experimental results. Okay, so you have to learn this skill, that how do you express your research work in a document. This is going to be a time consuming process. Okay, you will learn this particular art after a couple of manuscripts only. Okay, so transferring your thought process on a direct manuscript is going to be a little bit time taking process, right? So what I would suggest, okay, is that you take a piece of paper, okay, you write down kind of flow chart that what is the problem, okay, what is going to be the application, what has not been reported by others. Okay, all these things will go into the introduction part, right? And you figure it out what is going to be the new things in your area. Try to focus that more emphasis on the experimental results part. Okay, and try to make the story based on your experimental results. Okay, once you get this kind of a draft manuscript, okay, you ask your colleagues, okay, and ask your colleagues, your supervisor, to think from the reviewer point of view. Okay, try to find out what kind of loopholes are there in your own manuscript. Okay, and do not afraid of criticism. Okay, if your colleagues is telling no, your work is basically not good, you need to ask why you think that work is not good. Has it been reported by others? Okay, if the same work is reported by others, okay, do you have any, let's say, benefit, low cost, or for example, easy material, faster material removal rate, and so on, right? So you have to be really careful of that. Now, remember that once you submit a manuscript, you are not only reporting your own work, you are also reporting your supervisor, and more importantly, you are basically reporting to an institute level and for your country. That is very important. Okay, so if you submit any manuscript, okay, which has some of the basic fundamental flaw, okay, you are not only going to cause a problem to you, your supervisor, but also to your institutions and country. Okay, so I have seen a particular case, okay, where a Chinese research group has taken the almost more than 50% of the data from a published work of somebody else. Okay, and they have basically claimed that work as their own. Okay, and later on, okay, we had made objection to that particular work, and editor has to withdraw that particular paper. So it was very kind of a bad thing from that point of view. Okay, so while writing your manuscript, you need to ensure that your manuscript is free from fabrication of data, okay, falsification, and plagiarism. Okay, so fabrication of data, okay, providing data without doing an experiment. So for example, okay, let's say that I have indicated here that you need to show the error bars, right? You, okay, in any kind of a graph, you need to indicate your error bars. Now, if somebody has not done an experiment, okay, and simply taken some value of, let's say, 3 to 5% and reporting that particular data, okay, as a part of the experimental work, it is basically a fabrication of data. Okay, falsification, putting the wrong improved data. Okay, so you are, for example, you are getting a roughness value, let's say 5 micrometer, for example. Okay, you know that 5 micrometer roughness is not really good. Okay, if you have put it 1 micrometer, of course, okay, this is going to be under a falsification data, right? Plagiarism, okay, you are claiming somebody else, you are keeping some images, okay, somebody else reported statement without giving a proper citation. Okay, that is going to be under this. Okay, so all these three things are a very serious matter. Okay, and it is the responsibility of all authors. That's very important again. Okay, many times it happens within Indian academic environment that all the blame will go to the student. Okay, if something goes wrong or something, okay, supervisor will basically claim that he was not aware of that and it is fault of a student. Okay, but that is completely wrong thing. Okay, it is the responsibility of all authors to check about these three things. Okay, because when you are author, okay, you have to also be ready to claim responsibility. That is the key thing. Okay, so there are a lot of this kind of website. Okay, so if you want to check a English grammar related thing, there's something called grammarly.com, okay, which will help you. Okay, if you want to check whether plagiarism, or there's a website called urkundu.com or Turn It In, okay, which are available in this thing. Okay, fine. Okay, so now let's say that you are in the process of writing draft manuscript. Okay, so try to find out, okay, a particular journal. This is my personal recommendation. Okay, so you, okay, because after doing a literature review, you know which journal are good or not. Okay, what is their reputation, what is the acceptance rate, okay, what is the impact factor, and what is going to be the review period. These are some of the 4 parameters, okay, which you can basically consider that. Okay, so acceptance rate, typically, for example, a good journal, they have acceptance rate about 20%. Okay, so it means that out of 5 submitted manuscript, on an average, 1 manuscript is going to be accepted. Okay, so try to target one particular journal. Look, for example, read that some of the papers which have been published in that particular articles. Okay, learn the writing styles. Okay, so I always ask my students, okay, to, for example, target one journal, look at the journal, how they have written that particular article, okay, and try to formulate your manuscript similar to that. Okay. And since we are going to present our own experimental results, more emphasis should be given on the experiment, this part here, because this is going to be your main part. Okay. So your paper is a kind of a, a body, right? So experimental data results, okay, that is going to be the key thing. So my personal recommendation is that first you focus on that particular part, then your details, experimental details, then you go for introductory part only, okay, where you have to indicate, okay, the motivation, need of the work, and objective. It has to be extremely clear. Okay, that is a very, very key thing there. Okay, so you have to be absolutely clear in writing down this statement, that why this work is going to be needed. What is the need of carrying out this work? Okay. Conclusions. Okay. Many times it is seen that people write a very long paragraph on conclusion. Okay. My recommendation is that, okay, because the reviewer, they want to see kind of what is the really the conclusion. Okay, so it is good idea to indicate this conclusion in a bullet points. Okay, and that bullet point should be very, very clear, right? Two or three lines has to be there. Okay, abstract is very important, as you know that first of all, when a manuscript is sent to a reviewer, okay, we are only showing the abstract only. Okay, and we ask the reviewers, are you willing to review this manuscript? Okay, so reviewer only go through the abstract. If they don't like abstracts, okay, they will not be agreeing to review the full manuscript. Okay, so you have to put a very special emphasis on abstract, and abstract should be again very, very precise. It should indicate that what kind of work you are going to report in this particular manuscript, what has been done, and what is a novelty. Okay, so this is going to be very, very critical point here. Again, okay, as I said that since you have done work by yourself, okay, right? Since you are the one who has done all the work, you are very, very clear in your mind that what kind of work we have done, what kind of results we have got. Okay, but you have to transfer your ideas, your work on a piece of paper, right, or computer screen. And this is not going to be again easy task, because you will get very confused, right, that what to write first, what to know, how to indicate. Okay, so again, this is going to be a time-taking process here. Okay, so if you're not able to transfer, if you're not going to make others understand your work, then it is not going to be really easy for you to fill publication. Okay, so along with a good work, it is also very important for you to learn how to write down your thoughts on a piece of paper. That is going to be critical. Okay, so as I said that my personal approach is always to write down manuscript on a kind of a flow on a paper. So what I normally do in my own research work, I ask my students, okay, to prepare the images, okay, on a PowerPoint. So first I ask them that what are the images which you are going to present in that particular manuscript. Okay, show me on a PowerPoint. Okay, so typically a article will have about 10 to 12 images, including all the graphs. Okay, so I ask them, okay, just write down all those images and in front of me and show me. So once we finalize all the images, all the results, okay, after that we start writing down the manuscript on a Word. Okay, so that is I mean going to be my approach here. Right. Okay, so I think I've already indicated here manuscript. Okay, what are the different sections? Abstract, introduction, simulations, result, and discussion. As I already said, okay, the result and discussion, this is going to be the most important part here. Okay, you have to be very, very clear. Okay, one of the common mistake which I have seen, in fact, when I was a student, I have also done the same mistake, that we put down our figures, okay, tables, but we do not really explain that particular image, that particular figure in detail. Okay, so it is your job to indicate what is that picture is about. What are the special thing about that particular image, that particular picture? It is not a job of a reviewer. Okay, so all these pictures and tables, okay, if there's any special things, you have to clearly indicate that particular figures in the manuscript itself. Okay, right now I have already mentioned to you that conclusion should be preferably in the bullet points. One more things, which is a practical advice, which I found it useful, that try to put down a more number of references. Okay, so if you have a choice, okay, try to indicate more number of references. Okay, now it has a basically going to impact in one way. Suppose you have taken a references, okay, and your manuscript has gone to a particular researcher, okay, who has also published article in that area and whose reference you have kept down in your references, right? So that person is normally get a bit happy and satisfied that these authors have read it my paper. So normally I will have some kind of a positive feeling about this work. Okay, so my just recommendation is that try to put a more number of references, but those references has to be relevant. Okay, they should be like connecting your work to that particular reference. It should not happen that you are just to increase the number of references, you are keeping some references which are not really relevant. Okay. Finally, again, you have basically make a manuscript. Okay. Remember that manuscript is only a draft manuscript. Okay. There is going to be a lot of loopholes. Okay. It's the job of a supervisor, okay, to really read that particular manuscript, okay, and find out what kind of cracks you have, what kind of problems, what things is not correct. Okay, many times it happens that in many institutions, including IITs also, that a supervisor is not really reading it, the manuscript, or not reading it completely. Okay, so I would recommend that, especially when a PhD student is a new, okay, when this is his or her first manuscript or second manuscript, I would suggest, I would ask all the supervisors to really read through the manuscript so that they can basically tell that what kind of problems you have, what things need to be modified. Okay, so all these things are going to be a revising manuscript cycle. Okay, so you submit your work to your supervisor. Okay, he has some corrections, you correct it, then again go back to. Okay, so typically depending upon how busy your supervisor is, okay, you may have 1, 2, 3, 4 iteration of the manuscript. Okay, so don't be frustrated. Many times it happens that students also get frustrated because their supervisor is asking them to do more and more revision. Okay, but believe me, it is job of a supervisor to plug all kind of cracks, all kind of loopholes in your manuscript. Okay, now this is a very interesting cartoon. Okay, this is a review process, right? So you are the corresponding authors. Okay, you have a manuscript in your hand and you're going through this particular path. And this is a job of ours, okay, as an editor, as an associate editor, or as a reviewer, to find out problems in that particular manuscript. Okay, so if you have done enough work, okay, if you have already reviewed your thesis, this manuscript multiple times, okay, you are going to have less problem. Okay, so there's a very famous saying, okay, the more you sweat in training, the less you bleed in war, right? In our border movie also the same statement was written here, right? So idea here is very simple, that if you have done enough practice, okay, if you have are really careful, you and your supervisor both, okay, you will have a less problem in passing through this path, and you will have a high chances of your paper acceptance. Okay, and as an editor, as an associate editor, our role here is just to find out whether the manuscript is free from any kind of plagiarism. Okay, if the manuscript has any kind of fundamental flaws or not. Okay, and this is, if all of us are doing our work, then only we are able to contribute some kind of a really a positive contribution to our academic. Okay, so my editor perspective, as I already mentioned to you, okay, that what we normally look at the following things. Okay, whether the manuscript is under the journal scope. Okay, so every chief editor, okay, they need to find out, for example, whether the submitted manuscript is really under the scope of a journal or not, whether articles from the similar research domain have been published in that particular area. Okay, plagiarism check software, it tells you whether the author's present work, okay, what is the similarity. It should not happen that authors have published some images, okay, in previous journal, okay, same images have been basically published in this manuscript also. Okay, so even if you are using your own images, okay, of your own work, you have to put a proper citation. Okay, because once you submit a manuscript and manuscript is published, remember, you do not have any rights over that work. Okay, you are transferring your copyrights from you to that particular journal. Okay, so even though it was your own work, okay, you cannot really use it without taking proper citations. Okay, now let me tell you one practical facts, okay, which is a very common thing. Okay, authors and institution reputation does matter. Okay, whenever a new manuscript comes in to a tutorial, okay, no matter how we try to claim, okay, the reputation of the institutions, okay, and authors both matters a lot. Okay, so a manuscript which is submitted by let's say prestigious universities like, let's say, MIT or Berkeley, okay, it will have a very low chances of rejection, okay, compared to, for example, let's say IIT Bombay. Okay, within India, if I compare, for example, IIT Bombay have a good reputation, and probably it will face less chances of rejection compared to other institutions. Okay, now whether this thing is fair or not, okay, of course we can say that, okay, this is not fair, but let me tell you that these institutions, okay, they have worked for last 40-50 years, okay, to build up that kind of reputation. Okay, so this reputation matters, and same time, okay, this is also why I said that any manuscript has to be free from any kind of plagiarism. Okay, if you submitted manuscript is going to be having some problem, okay, it is going to affect, okay, the future manuscript from that particular researcher. Okay, so editors review first glance through the manuscript. Okay, they only look at the pictures, okay, mainly. Okay, so I would suggest that try to keep good quality pictures in the results sections. Okay, because as a reviewer, when some manuscripts comes to me, okay, personally I do not read it immediately, okay, because mostly we are a bit busy. Okay, so but what I do, I try to glance through all kind of a manuscript, okay, and we look at the pictures mainly, right, whether something is making sense or not, graphical images. Okay, so that will keep some kind of a positive impact if you have taken good pictures here. Okay, so try to include more and more pictures. Okay, so typically your manuscript goes to 2 or 3 reviewers. Okay, and if there's any kind of a split recommendation, one reviewer is saying it's a good manuscript, one is saying it's not, okay, then the associate editor has to take a decision. Okay, so this is a kind of review process which you typically encountered in your life. Okay, now this is also a very interesting thing. Okay, so this particular slide I have kept it deliberately, okay, because many times it happens that manuscripts are rejected, okay, and we feel very disappointed. Okay, but believe me, okay, well-known work has also been rejected in past. Okay, I have taken 3 examples, there are many more. Okay, so 2019 Nobel Prize work, okay, in medicine, okay, Dr. Peter, his work was rejected by Nature Journal in 1992, okay, saying that it was not good. Okay, Peter Higgs, I think most of us know that, who has presented a Higgs model. Okay, his short paper was also rejected in 1964. Okay, the same guy went on to win the Nobel Prize and so on, right? So why their paper was rejected? Okay, it means that most likely either they were not able to clearly write down their manuscript, or clearly try to convince the reviewer that this work is good. Okay, because work was good, right? Because they have got a Nobel Prize for that. Okay, so either they could not basically convince the reviewer, or the reviewer themselves could not understand what is exactly talk about. Okay, so my suggestion is that do not worry too much. Okay, if your manuscript is rejected. Okay, okay, what you have to do is, okay, you have to look through the review, you have to take the comments by the reviewers, okay, and try to include those comments, okay, while you are revising your manuscript and you are submitting to some journal else. Okay, so in most of the journal cases, the manuscript which has been rejected from a particular journal, okay, the same journal will not consider that manuscript. Okay, so you have to submit somewhere else. Okay, Now, this was my last slide. So as I said in the very beginning, okay, so I was planning to make it as a kind of more informative and discursive section. So I'm sure that you guys will have a lot of questions, okay, and okay, so I'm ready to answer your questions if you have any.
Yes, participants, if you have any query or anything you want to discuss with sir, you are welcome. You can also drop a message in the chat box.
Yes, please feel free, because this is going to be a kind of FTP program, right? And I want to share like my own opinions, my own thoughts process based on that. Okay. So let me pause. I'm going to stop the sharing. Yeah. If you have any questions, please feel free. Somebody is asking, please list some of the journals. How to select a journal for a research write-up. So as I said already in the beginning, right? So once you know, I mean, if you have read some papers, right? You know which are the good journals, which are not, right? So a good journal is something which I would say that which is running, let's say, from last 20-25 years, okay, on average, which has a sufficient good impact factor. Okay, and by reading those articles, you can find out, okay, whether the content of the journal published article content published in that particular journal, okay, is good. Okay, so these things are like a personal one. I can tell you from the manufacturing side. Okay, so JMPT, JMP, IJMT, okay, they are all good journals. Okay, remember that most of us are working on an engineering field. Okay, so when you are in engineering field, publishing paper in like a science related journal, for example, physical regulators, okay, is going to be more challenging. Okay, I would say, okay, somebody asking about publication in conference paper. Remember, okay, conference proceedings are not considered as a journal. Okay, I am getting this application for a postdoc from NITs where people are also keeping it conference journals. Okay, they are not counted as a journal paper. Somebody is asking how to confirm this is a proper research gap, how to identify research. So research, let's say that somebody, let me just tell you. So coming back to the same problem which I said it several times, if you want to create a deep holes, right, micro holes in a glass material, right, find out what is the maximum aspect ratio, what is the maximum depth people have achieved. Okay, can you push forward? Okay, can you really create 1 millimeter depth holes? Okay, what are the technical challenges you need to ask yourself, why people are not able to create such kind of a like holes or not, right? So you need to really look at the problem and try to ask yourself what are the reasons. Okay, and then you need to find out. For example, I can tell you that when we try to create holes in a glass material, okay, we are having this kind of a sludge, okay, sludge or the reaction product. Okay, now if you're creating a blind hole, the reaction product has to come out. Okay, but many times it is not, there is no mechanism. Okay, so you need to ensure, okay, that there is some kind of proper mechanism which is basically useful for creating or removing the sludge. If you're not able to remove the sludge, you are not able to create high aspect ratio features. Okay, computer science and engineering, sorry, I am not able to, because I'm not from computer science and engineering, I cannot really tell you. But most of the IEEE journals are good. Okay. How to select the journal for research write-up? So Mr. Navid Akhtar is asking. So I mean, once you are writing a research proposal, right? Okay. Again, the quality of the journals will remain same, right? So whether you're writing a publication or you're writing a write-up, okay, it is not going to matter a lot. Okay, but quality should be the same. That's the one key thing. My only suggestion or recommendation to all of you, whether you are a faculty member or a student, okay, is just to be ready to ensure that your manuscript does not have any kind of plagiarisms, falsification, okay, that's one key thing, and plagiarism, okay, that is the typical challenges which we see in most of the manuscript, okay. That's one of them.
Yes, participants, any query?
So again, let me read it. So Mr. Nidrul Prabhakaran is asking question. Some experimental work is completed. It is novel work, but how to write it? It is a research gap. So if it's a novel work, it means that it has not been reported earlier. Then this is going to be research gap, right? What is the best order of writing a journal? So as I said that if you once you have completed your experimental work, right? My personal recommendation is that write down experimental results and discussion part first. Okay, then you write down experimental details. Then you indicate about the introduction, because introduction is not that critical. Okay, the most important part is going to be experimental result section. Okay, so discussion, then details, then introduction part. Once you complete, then write conclusion, and at the very last you write down abstract. Yeah. Can I know acceptance level of paper having literature review?
I think, sir.
Sorry. I think those who have questions, they can also write down to me directly. Okay. I think I have given my email address. It's very simple. pradeep.dikshit@itb.ac.in. Okay.
Sir, I think there is no more query now.
Okay.
We are very much thankful for your valuable presentation for how to write a manuscript, not only for beginners, for all of us, and how to avoid plagiarism. Thank you very much, sir. Thank you for your valuable talk.
Yeah, it is my really pleasure to interact with all of you. Thank you very much. And let's write down good manuscripts. Okay. Thank you. Shall I leave now?
Hello, sir. Okay, participants, our next session will start at 2:30 p.m. Thank you very much.